Exercise 1. Find the coordinates of the point of intersection of the function f of x and the function g of x. So this is one function, and here's another function, and they're going to intersect at some point, and we would like to find the coordinates of these points or point. So probably just one intersection. First of all, let's write down the functions here. F of x is equal to, and then x plus 1 over x minus 1. The other function is called g, the function of the variable x. So g of x is equal to half x plus a half, so 1 over 2 x plus 1 over 2. This happens, well, the intersection happens when the y value is the same, for example, and then we can find out the x value for that. So let's say that we just do a sketch here. Let's say the function might look, just an example, maybe something like this, something like this, we don't know, something like that. And the g of x might be a line, and then let's see, maybe something like this, and then we have, of course, one point here where they intersect and one point here. So we're using this method, that is, at this point, this function g of x and this function f of x, in this point they have the same y value. Okay, it doesn't happen here. For example, if we take this x value, we go here until we meet the f of x function, and we have this y value, and if we go up here, we meet the g function here. It has this y value. So for this x value, they don't have the same y value here, but this happens for this x value. If we go up here, both have the same y value. Same here, if we take this x value, we see that for this point they have the same y value. So that's what we're trying to take advantage of. We know that this is the connection. So we just have to solve f of x is equal to g of x. Set them equal to each other. Remember that f of x is also sometimes called the y value. Sometimes you see y is equal to in this expression, or y is equal to this expression. So when is y equal to y for both functions? Okay, so I'm just gonna do this equal to a half x plus a half. Now I have to move things around before I can get closer to solving this equation. It's difficult to guess for which x values this is true when this is equal to this. I'm going to take this denominator and move it up here, then I will multiply it with everything on the right side. So the next step would be x plus 1 is equal to, I'm just going to write this thing within brackets, then I multiply it with this, the denominator on the left side. I bring it up here on the right side, and next step would be x plus 1 remains the same. Let's expand these brackets. Let's work this out. I'm gonna move it down a little bit. So half x times x is half x squared. A half x times minus 1 is equal to minus a half x. A half times x is equal to a half x, so plus a half x. Now we see that these two terms will cancel out. The last thing is a half times minus 1 is minus a half. So we can just cross this out. Minus a half x plus a half x will cancel out. We're left with this and this term on the right side. Let's bring everything to the right side. Then we would have 0 on the left side, and then a half x2. That's the only x2 term. And then this x becomes minus x, and this plus 1 becomes minus 1, and then we still have the minus a half here. Let's clean up a little bit. I'm gonna just swap sides, so I'm gonna have this on the left side. If 0 is equal to this, it's the same thing as saying this is equal to 0. So we can just bring everything to the left side. This is the x2 term, minus x, that's the x term, and then we have minus 1 minus a half is equal to minus 3 halves. Now, we can use the general formula. Remember, x is equal to minus b plus minus square root of b squared minus 4ac. And what is, let's see, don't forget this one. What is b and a and c? Well, in order to use this general formula, we have to have an equation on this form, ax squared plus bx plus c is equal to 0. If it looks like this, we're able to solve this equation. So we have to figure out what is a. In this case, it's the half here. And then what's the b term? Well, it's actually the minus 1 that is in front, the x that we don't see, but it actually says minus 1 times x, but we don't write it out. But we know that b is minus 1. And the constant term, c, is, don't forget the minus sign, it's minus 3 halves. It's not 3 halves, it's minus 3 halves. Now, x is equal to, and of course we have to write is equal to 0. Okay, that's the equation. X is equal to minus b, well, minus b, so I'm going to write it out, minus b, and b is minus 1. This will eventually be plus 1. Then plus minus, and then the root symbol. Let's do this first and see what we have to fit under the root sign. B squared, so minus 1 within bracket, because we have to square it, including the minus sign, minus 4 times a within bracket means times 4 times a half times c minus 3 over 2. And then everything divided by 2a. Let's clean up a little bit. Minus minus 1 is equal to 1, plus minus, within the square root here, we're going to have 1, because minus 1 squared is 1. And then, if we have a look at this, it's down here in the denominator is times 2, up here is the 4, they're going to cancel out, and then we're left with minus 1 times minus 3. If you feel like this is too much to do in one step, you can write it out in several steps. For example, you can take minus 4 times a half. So minus 4 times a half is equal to, of course, minus 2. And then you take that minus 2 times minus 3 over 2. And then you're going to see that this is going to be, you can cancel out a 2, and this becomes -1, here's 1, -1 times 3, 3, okay? So, as long as you don't do the mistakes, it's easy to do a mistake and forget a minus sign. So, this became 3. And everything divided by, we didn't write a, so a is a half, 2 times a half is 1, so we don't even have to write divided by 1, we're just going to leave it like that. Let's clean it up a little bit more. Plus minus square root of 1 plus 3 is square root of 4, which is equal to 2. Now we have two solutions. 1 plus 2 and 1 minus 2. So 1 plus 2 is equal to 3 and 1 minus 2 is equal to -1. Okay? So going back to the question, they want us to find the coordinates of the point of intersection. Now we only have the x values. We'd like to have the coordinates of the point. So how do we get the y values? Well, we just substitute 3 and -1 for x in any of the two functions. Remember, since they intersect, it doesn't matter if we choose f or g, because they're going to be the same y value anyway. So I'm going to choose the easiest function in this case. It doesn't really matter, so I'm going to use the g function. Okay, so g, let's do it here actually. So g of, and then we have to remember the roots, the x values, 3 and -1, so g of 3, and we have to find out g of 1. G of 3 is a half times 3 plus a half. Oops, a half is equal to 3 halves plus a half is equal to 4 halves, which is equal to 2. A half times x, x is 1 plus a half is equal to, a half plus a half is equal to 1. Therefore, the two coordinates for the first point of intersection are 3, 2. What am I doing? 2. And then 1 comma 1. Now, even though this was an exercise without the calculator, let's just check the result and confirm. So, fraction x plus 1 divided by x minus 1, that was the function, right? X plus 1, x minus 1. Then a half x plus a half. Tab a half times x, and then plus another fraction, 1 over 2. And here we see that something is not right. So let's have a look. The points of intersection is quite easy to see, but let's analyze the graph. Intersection, go a little bit to the left, a little bit to the right, 3, 2. We got that one right. And then analyze graph, intersection, and this should be -1, 0. So what is wrong? First of all, we got 3 minus 1. Did I use the right coordinates? Let's have a look. The x values were 3 and -1, and I used 1. That's why it's incorrect. So g of minus 1 is equal to a half times minus 1 plus a half, and that is equal to 0. Okay? So minus a half plus a half is equal to 0. So 1, 0. Okay, that was a mistake. And now we've checked the result. 3, 2 and 1, minus going too fast. Let's see. Minus 1, 0. 3, 2 and minus 1, 0.